Good morning, student. Today we will consider the example on the root locus. So for the system g of s is equal to k over s into s plus 1, s plus 2, and h of s is equal to 1. So this is unity feedback system. We have to sketch the root locus for this given system. So the angle condition, we have to check the angle condition. So angle of g of s is equal to angle of k over s into s plus 1 into s plus 2. So this is angle condition, and we have to do like this minus. So there are no open loop zeros, only 3 open loop poles are there at s is equal to 0. This is s is equal to -1, this is s is equal to -2. So angle condition is equal to minus s of s minus s plus 1 and minus s of minus angle of s plus 2. So this is equal to plus minus 180 degree into 2k plus 1 for k is equal to 0, 1, 2, and this is up to n minus m. Okay. So where this n is the number of open loop poles and m is the number of open loop zeros. So open loop poles are here 3. So 3 minus 0. So we have to go for only 0, 1, and 2. We have to substitute the values of only 3. That is k is equal to 0, 1, and 2 in this angle condition. So next is the magnitude condition. Magnitude condition we have seen in the theory that magnitude of g of s is equal to k over s into s plus 1 into s plus 2 is equal to 1. So this, the open loop poles are at s is equal to 0, s is equal to -1, and s is equal to -2. So in the complex s plane. Okay, so s plane, and if the test point is on the real axis, positive real axis. If the test point is suppose on this positive real axis, so this is a suppose test point, what will happen? The angle is 0. Angle made by this first pole s, this s plus 1, s plus 2, this is all will be 0, and therefore angle condition is not satisfied. Therefore the portion between 0 and the test point on the positive real axis is not part of the root locus. Okay, so now consider the test point is on the negative side. So this is on the negative side, and the test point is supposed between 0 and -1. So we have considered the test point is here between 0 and -1. So angle made by this S1 is 180 degree, and again angle made by these two poles S plus 1 and S plus 2, this is again 0, but the here condition is satisfied because angle of S is equal to, it is 180 degree, and angle of S plus 1 and S plus 2 is 0. Okay, so this is the 180 degree, but angle made by this S2 and S3, these are the 0. Here the condition is satisfied. Therefore, this is the portion of the root locus. This is not the portion of the root locus. This is the portion of the root locus. Okay, now consider the test point between -1 and -2. So we will consider the test point is here. So again we have to check the angle condition. So angle made by this first pole will be 180 degree. Angle made by the second pole is also 180 degree, and angle made by this third pole will be 0. So total angle is 180, and this 180 360. Therefore the condition is also not satisfied. The angle should be equal to 180 degree, and therefore condition is not satisfied even if the test point is between -1 and -2. Therefore this portion is also not the part of the root locus. Okay, therefore this portion is also not the part of the root locus. This portion is also, this is not the part of the root locus. Okay, because here the angle made by this S1 is 180 degree, S2 is also 180 degree, but angle made by this is 0 degree. So 180 plus 180, it is 360. We require the 180. Therefore, the angle condition is not satisfied. Angle condition is not satisfied, and therefore the portion between 0 and -1 is not the part of root locus. Okay. So we have seen up to this. Now we have to find the asymptotic angles. So angles of asymptotes. This is equal to plus minus 180 degree 2k plus 1 by n minus m. So what is n? N is the number of open loop poles where k is equal to 0, 1, 2 up to n minus m. Okay. So here n is equal to 3. That is the number of open loop poles are 3. At s is equal to 0, at s is equal to -1, and at s is equal to -2. And the number of open loop zeros are 0. Therefore, n minus m is equal to this 3 minus 0 is equal to 3. And therefore, we have to take k is equal to 1, 0, 1, and 2. So, 3 values we have to take. And if you take now k is equal to 0, what will be the angle of asymptotes? Angle of asymptotes is equal to, if you put here, so it is a plus minus 180 degree by 3. So this is equal to 60 degree. So this is a plus minus 60 degree. And one more, you can substitute here k is equal to 1. Therefore, angle of asymptotes so here consider k is suppose 1. So it is a 180 degree. So it is 180 degree and k is equal to 2. So angle of asymptotes is equal to 180 degree and 2 into 2 plus 1 by 3. So it is 180 degree. This 4 plus 5. So this is 300 degrees. So either 300 degrees or minus 60 degree. Okay, or minus 60 degree. Okay, so these are the angle of asymptotes that will be required while drawing the root locus. Okay. So there are 3 asymptotes. One having the angle of 180 degree is the on the negative real axis. Now we have to determine the breakaway points. Breakaway point. How this breakaway point can be calculated? By using the characteristic equation. If you know, if you have the characteristic equation, we can write the characteristic equation in this form, and what we differentiate k with respect to the s and equate it to the 0, we'll get the breakaway points. So we have the characteristic equation with us like this: g of s 1 plus g of s h of s is equal to 0. So here h of s is 1, so 1 plus k over s into s plus 1 s plus 2, this is equal to 0, and therefore s into s plus 1 s plus 2 plus k is equal to 0. Okay, we are interested here for finding the value of k because we have to differentiate with respect to the s. So we will solve this equation for k, and therefore it is a okay. So we'll get here, if we solve this, k is equal to minus, and this is s square plus 2s 3s plus 2, therefore this is minus s cube plus 3s square plus 2s. Okay, now differentiate this k with s and equate it to the 0, therefore 3s square plus 6s plus 2 is equal to 0. Okay, now find the roots of this equation. We will get s is equal to minus 0.4226 and s is equal to minus 1.5774. So initially we have seen that the test point we have considered between on the positive real axis, this is not the part of the root locus. Okay, this is not the part of root locus. This is only the part of root locus. This is not the part of the root locus. So what should be the breakaway point? The 0 and minus 1, having the value 0 and minus 1. So we have got what is the 0 and minus 1. So this is the value between 0 and minus 1, and this is not the value between 0 and minus 1. Therefore, this is a valid breakaway point. This is valid breakaway point. This is not the valid breakaway point. Okay. So the breakaway point must lie on the root locus between 0 and minus 1. So it is clear that s is equal to minus 0.4226 corresponds to the actual breakaway point. Okay. So this is actual breakaway point. Now next point is breakaway point. Now next is where to determine where the root locus crosses the imaginary axis. The point where the root locus crosses the imaginary axis. How we can calculate this? We can calculate this by using the route stability criteria. By route criteria, we can determine this. We have the equation with us, characteristic equation with us. This is your characteristic equation. S into S plus S into S plus 1, S plus 2 plus K is equal to 0. Okay, so this S square plus 3S plus 2 plus K is equal to 0. So this S cube plus 3s square plus 2s plus k is equal to 0. So this is your characteristic equation. Therefore, we can form the Routh array. Routh array s cube, s square, s1, s0. So it is 1, 2. This is 3 k. So this is 6 minus k by 3, and this is k. Okay. So to make the value of k, that makes s1 term in the first column equal to 0. Okay. So here, what should be the value of k, that so that this will become 0? So k should be equal to 6. If you put k is equal to 6 in this equation, this will become 0, and therefore this the crossing point on the imaginary axis can be found by solving the auxiliary equation obtained from the this will be the auxiliary equation just above the 0 rows auxiliary equation. Therefore, the auxiliary equation, it is a 3s square plus k is equal to 0, and the value of k is 6. 3s square plus 6 is equal to 0. 3s square is equal to minus 6, and therefore s square is equal to 2, and therefore s is equal to plus minus j root 2. Okay. So the at the crossing point on the imaginary axis, the frequency omega is equal to plus minus root 2. Okay. And the gain corresponding to this crossing point is 6. So the frequency is equal to W is equal to plus minus j root 2, and k is equal to 6. So in this way we can calculate the frequency and gain k. Now we can draw the root locus. Root locus can be drawn like this in the S plane. So this is the sigma, and this is j omega. Poles are at S is equal to 0. This is at S is equal to minus 1. This is at S is equal to minus 2. Okay. And what was the breakaway point? Breakaway point was this, and the value of this breakaway point is minus 0.4226. This is minus 0.4226. So the root locus, it will start from open loop poles, and it will move in this direction. This will move in this direction, and the second root locus will move in this direction. They will meet at this point, and this is the breakaway point. By meeting at this point, they will break away, and one will go in this direction, another will go in this direction, and this will be the angle. By making an angle of 60 degree, it will go in this direction, and this is by making the angle of minus 60 degree, it will go in this direction. And the third root locus, it will start from S is equal to minus 2, and that will go in this direction. So here k equal to infinity. Here the value of k is equal to 0. The value of k is also equal to 0. And this point crosses the imaginary axis where frequency is equal to plus j root 2. Here the frequency is equal to minus j root 2. And what is the value of k here? K is equal to 6. The value of k is equal to 6 here. So this is the root locus plot for the given example. Thank you for watching this.